One of the most practical uses of z-scores is to compare scores from different distributions. Have a look here at two marks that two different students got. Greg received an 80% from his Spanish class, and the Spanish class statistics are here. So we've got a mean of 75 in the class and a standard deviation of 2.5. Well, Mike got an 80% in his English class, and so again we've got the mean and the standard deviation listed. Who got the better mark? Well, they both got an 80%, so they both got the same mark in that respect, but within the context of their own classes, things change a little bit. Now, both classes had an average that's the same in this example, so both classes have an average of 75, so they both did better than average by 5 marks, but you'll see here that the Spanish class had not as much variation as we've got in the English class. So we have two different distributions. So we've got 2 marks from 2 different distributions. We want to make a comparison of those. Z-scores can help us do that. I'm going to do a Z-score for Greg, and over here I'm going to do a Z-score for Mike. And I'll show these back to back. So actually let's do this in a easier to see color. Z-scores are x minus the mean over the standard deviation. It's going to be the same formula for both of them, but of course I'm going to have two different sets of scores here. Greg has a raw score of 80. He's in a class where the mean is 75 and the standard deviation is 2.5. This gives me a 5 over 2.5, and that is a z-score equals to 2. Mike, on the other hand, also has an 80 and is also in a class with a mean of 75, but Mike's class has a standard deviation of 5. So this will leave me with 5 divided by 5, or a z-score for Mike of 1. So they have two different z-scores. What does this mean? Well, if I were to draw these on a distribution where z equals to 0 is at the center, you would see that I've got Mike right here at 1, so that is Mike, whereas Greg is twice as far ahead. Greg has a z-score of 2, so hooray for Greg. Greg has the higher score when we put these two different contexts into a standardized distribution. So we compare the two scores by converting apples and oranges to apples and apples. We've converted our scores to z-scores so that we can compare scores properly from two different distributions. Because you can see that 80 and 80, these are both the same. They both have the same means, but we need to take into account that we have two different distribution shapes, two different distribution spreads. And so this does that for us. Z allows us to take scores from two different contexts and compare them properly.